This video is the second part of the ongoing video tutorial series on CCNA. In this video, I will explain how to download, install, configure, and use Packet Tracer Simulator software. Packet Tracer is network simulator software. It can simulate all essential Cisco devices we need to practice CCNA exam topics. Earlier, only NetAcad students were allowed to download and use Packet Tracer. Later, Cisco allowed everyone to download and use it. You can download the latest version of Packet Tracer from its official website. Open a web browser and search for the term Packet Tracer. It is the official website for Packet Tracer. Open it. You need a user account to download the Packet Tracer. If you already have a Cisco Network Academy user account, you can log in using that account. If not, create a new user account. Creating a new user account needs only a valid email address. If you have a Gmail account, you can use it to log in. If not, create a user account and use that to log in. After logging, visit the Resources section and click Download Packet Tracer. It takes you to the download page. The download page provides download links for Windows, Ubuntu, and Mac OS. Download the installation file that suits your computer's operating system. Downloading takes a few minutes. After downloading the installation file, open the download directory and click the installation file. The installation process is straightforward. On the first screen, accept the license agreement. The next screen allows us to customize the installation directory. By default, it installs Packet Tracer on the Windows partition. To install it on another partition, use the Browse button and select that partition. Select your desired location and click Next. The next screen creates a shortcut link in the Start menu folder. The next screen also allows us to create two more shortcuts. This option places a shortcut on the desktop. To access it from the Quick Access bar, click this option. That's all the information the wizard needs. Click the Install button to start the installation process. The installation process takes a few seconds to install Packet Tracer on the system. The last screen allows us to start Packet Tracer. Click Finish to close the wizard. On the first run, it asks how we want to use it. The multi-user mode allows you to share labs with network users. For personal use, click No. You need a Cisco account to use Packet Tracer. You can use the same account you used to download it. After logging in, you can simulate Cisco devices and use them to create practice labs to practice CCNA exam topics. If you are on a shared computer, you can log out from Packet Tracer after completing your practice. The File menu has the Logout option. If you log out, you must log in again to use your saved labs. If you are on a personal computer, you can stay logged in to skip the login each time you start Packet Tracer. So far, we have learned how to download, install, and set up Packet Tracer. Now, let us get familiar with the interface. The first thing we need to know is the device menu. It is available on the bottom left side. It provides all the devices we can simulate and use. It has three sections. The top section shows the categories of devices. The middle section shows the name of the selected category and allows us to search devices. The bottom section displays subcategories of the selected category in the top section. The right side of the device menu shows all devices of the selected subcategory in the bottom section. Let us quickly go through these devices. Here, we have 6 device categories. Network devices, end devices, components, connections, miscellaneous, and multi-user connections. The network devices category includes routers, switches, hubs, wireless devices, security devices, and WAN equipment. The end devices category provides the end devices we need for testing network configurations. It includes PCs, laptops, smartphones, TVs, and servers. To simulate a real-life network, it also includes many home appliances, such as fans, bulbs, doors, music players, power meters, and sirens. It also includes commonly used items in a city and industry. The components category includes programmable circuits. You can control these from the network devices using a programming language. The connections category provides the connection you need to connect network and end devices. The miscellaneous category includes devices relevant to previous versions of the CCNA exam. The multi-user connections category provides settings you require to use Packet Tracer in multi-user mode. Network devices, end devices, and connections are the main in these categories. The network devices category provides network devices we configure in the CCNA exam. The end devices category includes devices required to test the network configuration. The connection category contains cables to connect the network and end devices. All networks and labs reside in the workspace. This large white area is the workspace. We create labs and network on it. Let us build a simple network that connects 2 LAN networks through a router. We have two options to add a device to the workspace. Click the device you want to add and click on the workspace where you want to add it. You can also drag the device to the workspace. Select the device, drag it to the workspace, and drop it where you want to place it. We need a few more PCs. We can also copy and paste devices on the workspace. Right now, these devices are standalone. They are not part of any network. A network connection adds a device to the network. Different devices use different types of cables for connectivity. In the beginning, you need to understand only 3 cable types. These types are copper straight through, copper crossover, and serial. These cable types connect PCs, switches, and routers. Copper cables connect with LAN ports. Serial cables connect with serial ports. A copper straight through cable connects an end device such as a PC, laptop, or server to a hub or switch and a switch to a router. A copper crossover cable connects an end device to a router, a switch to another switch, and a router to another router. A serial cable connects a router to another router. Since a serial cable connects with a serial port, you can use it only when both routers have serial ports. Now, let us create connections between these devices. Click the cable type. Click the first device. Select the port. Click the second device. And select the port. Repeat the same process and connect the second PC to the switch. There is also an auto connection option. This option automatically creates the necessary connection between devices. You can use this feature to speed up the lab building process. This feature works similarly to manual connections. Click the first device, go to the second device, and click it. Connect PCs to the switches and switches to the router. It is our first LAN network. It is our second LAN network. This router connects these networks. Currently, we are viewing this network in the logical mode. In this mode, Packet Tracer shows how devices have connectivity and access each other. To view these devices in realistic mode, click here. It changes the workspace's display mode to physical. In this mode, it shows the network location. In the first video of this series, we learned about the 3 types of networks: LAN, MAN, and WAN. This mode allows you to determine your network type based on its physical location. Let us switch to the logical view again. Most of the time, we work in the logical mode. We use physical mode only to view how the network looks in real life. Now let us understand these tools. This option allows us to select devices on the workspace. This option lets us view the dynamic data the device collects for various functions. This option deletes the selected device from the workspace. You have a few more tools here. This option resizes the devices. You can use this option to place a note on the workspace. Notes make lab descriptive. You also have drawing tools. You can use these tools to add information to the network. Instructors use these tools to add information and descriptions to labs they create for students. If you want to change or delete a shape, you can use the delete option. Shapes and notes only add information to the lab. They do not interfere with the workflow. These tools add data packets for testing. You can track added data packets here. We have a few more self-explanatory tools here. You can use these tools to create a file, open an existing one, save the current file, copy and paste devices, undo, redo, zoom in and zoom out. Now we have a basic understanding of the interface. Let us move back to the network. If we click a device, it opens the device settings. These options depend on the device type. If it is a network device, you will see the physical, config, CLI, and attribute options here. The physical tab displays the physical layout of the device. If it is a modular device, this tab allows you to add additional modules. There are 2 types of devices, fixed ports and modular. A fixed ports device does not allow us to change its ports. A modular device is flexible. It has slots that we can use to install ports. This section lists all supported modules. When we click a module, this section provides information about its ports. If the selected device is a fixed ports device, there will be no module here. For example, a 2960 switch is a fixed ports device. On it, we will see no module here. Modular devices are more expensive than fixed port devices. But they add flexibility to the network. In real life, based on your requirements and budget, you can choose fixed ports, modular devices, or both types of devices for your network. On simulator software, you should select modular devices. If you select a modular device, you can add or remove modules only when the device is powered off. If we add a module when the device is powered on, it shows an error message indicating that the module cannot be added. To install it, we must power off the device first. Turn off the device. Now, add a module and power on the device. The same rule applies when we remove a module. We can remove a module only when the device is powered off. Power off the device. Now, remove the module and power on the device. Updating modules becomes essential when the device has no supported port for the required connection type. For example, we want to connect two routers on a serial connection. The first router has a serial while the other has only LAN ports. In that case, we must install a serial port on it. After adding or removing the necessary modules, we configure device settings. The Config tab allows us to update essential settings. The CLI tab simulates the console connection. We can configure all settings from here. The main difference between both tabs is that CLI is a fully functional console connection, while Config is a packet tracer-only feature that allows you to configure essential settings. Cisco devices run on the iOS operating system. An iOS is a Cisco proprietary operating system. Cisco developed it for its devices. By default, it provides a CLI interface for management. The CLI tab simulates this interface. To use this interface, you need to understand commands. You can use the Config tab until you learn the commands. The Config tab options run necessary commands for you. Let us assign the IP address to the connected interfaces. We will learn about IP addresses in upcoming videos. By now use these IP addresses. As you can see in this section, it automatically runs the required commands to implement this configuration. We can get the same result by running these commands on the CLI prompt. The Attributes tab shows the device statistics. An end device has slightly different tabs. It has two additional tabs, Desktop and Programming, and does not have a CLI tab. The Programming tab allows us to configure and run a Python script. The Desktop tab contains all the tools we need to configure and test an end device. The IP configuration tool allows us to assign IP address. Every end device needs a unique IP configuration. Two end devices cannot communicate without having a valid IP configuration. An IP configuration includes an IP address, a subnet mask, and a default gateway IP address. The IP address provides a unique identity to the device. The subnet mask categorizes IP addresses and divides the network portion from the host portion in the IP address. The default gateway is the IP address of the router's interface. Assign an IP configuration only on the router and end devices. We do not need to configure any setting or assign an IP configuration to switches. Now this lab is ready. We have many tools to test this setup. The most basic and widely used tool is the ping command. Open the command prompt. The ping command needs the IP address of the destination device. It sends dummy data packets to the destination device. If the destination device is up, it replies. The command prompt lists the responses it gets from the destination device. If you see reply messages, devices have connectivity. By default, Packet Tracer works in real-time mode. In this mode, it simulates the actual data flow. In simulation mode, we can control the data flow. By default, it tracks many protocols and services. To view the data of a particular service, we must uncheck all other services and protocols. For example, if we want to see the data of the ping command, we will uncheck all protocols and services and then check only the ICMP protocol in the IP4 section. Now let's start the event tracking. In this mode, Packet Tracer shows how devices forward and receive data in the network. The workspace displays the movement of the data packet. This section provides detailed information about the data packet as it travels in the network. These buttons control the data flow. This button resets the simulation. Click here to switch to real time. So far, we have discussed all the essential features and functions of Packet Tracer. Now let us understand the most used options in the menu bar. The File menu includes file management related options. It creates a new file. It opens an existing file. It saves the current file. It allows us to save the current file in a different location. It prints the current lab. It logs out the current user. The Edit menu includes copy, paste, undo, and redo options. The Options menu includes the Preferences option. It allows us to customize the interface. For example, these options show or hide the device's model number and name. The Font option controls the size and face of the font. These options configure the fonts for the CLI interface. This option customizes the interface's font. That's all the options and features we need to learn to use Packet Tracer. We will use it to create and test CCNA labs in upcoming videos. Finally, let us take the CCNA exam questions from this video. Type your answers in the comment section. I will check and let you know the result.